Alright guys, we are moving on to 5.4 today. This is the SSS triangle congruence. This, if you can't guess, stands for side, side, side. I bet you couldn't guess that, could ya? Well, alright, so explain one. Justifying the side, side, side triangle congruence. So the congruence theorem itself states that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So in this example, we have triangles that say AB is congruent to DE and AC is congruent to DF, and we have BC congruent to EF. See our little tick marks or hatch marks. So triangle ABC is congruent to triangle DEF. So let's look at the justification. So we have, we want to transform triangle ABC by translation along vector AD so that AB and DE coincide. The segments coincide because they're the same length, as you can see here in the diagram. So then, does a reflection across AB map point C to point F? Well, to show this, we can notice that CE, which is this side here with the 3 tick marks, is equal to DF. Or excuse me, to DC is equal to D. Wait, what did I do? DC. Oh, I'm on the wrong one. DC, here where point A is, it can be called by either point. So DC or AC is equal to DF over here. And that means that point D is equidistant from point C and point F. Then point D lies on the perpendicular bisector of CF by the converse of the perpendicular bisector theorem, because EC, this side, is equal to EF, this side. The point E also lies on the perpendicular bisector of CF. So point D is here, lies on the perpendicular bisector of CF, and EC, point E, also lies on the bisector right here. So then, since point D and point E both lie on the perpendicular bisector of CF, there's a unique line through any 2 points. DE is the perpendicular bisector of CF. So now we have this vertical line here. So by definition of the reflection, the image of point C must be point F. Therefore, triangle ABC is mapped onto triangle DEF by translation, followed by a rotation, followed by a reflection, and the 2 triangles are congruent. So let's look at this next example. We can show that triangle ABC is congruent to triangle PQR. So we want to transform triangle ABC by a sequence of rigid motions to form the figure below. So identify the sequence of rigid motions. And the proof's on the next page, but let's do the sequence of the motions. So if we were to take a copy of ABC and translate it, we want to move it, use a rigid motion and move it so that A lines up with P. So if we were to do that, it would come down here and it would line up like this. Well, what kind of transformation is that? That is a translation along vector AP. So then, now that we've got this figure, we want to rotate it to transform this triangle ABC so that it lines up like it does here in the picture, here to the left. So to do that, we're going to rotate. We want to rotate this one around. So sort of like that. Just rotate it around so that it lines up. And if you do it properly, it lines up just like this picture here. So then what sort of transformation is that? It's a rotation, which we just obviously just did, rotation. So it's a rotation about P. So A, B, and PQ coincide. So then what's the third thing we have to do so that this triangle maps on top of the other one? We have to do a reflection, right? Well, reflection over PQ, or you could say over AB, either would work, over PQ or AB. Okay, so now the proof here at the top of the next page is that, so, oops, stop. So QR is congruent to, and I copied our picture over here to the right so we can still see it while we fill in this. QR is congruent to BC, and point Q is equidistant from C and R. Therefore, by the converse of the perpendicular bisector, theorem, point Q lies on the perpendicular bisector of our C. So then PR is congruent to AC. So point P lies on the perpendicular bisector of RC. And then because 2 points determine a line, the line PQ is the perpendicular bisector. Oops. Bisector of RC. So then by the definition of reflection, the image of point C must be point R, and therefore triangle ABC is congruent to triangle PQR because triangle ABC is mapped to triangle PQR by a translation, a rotation, and a reflection. All right. right. Let's look at an example. Using rigid motions and the converse of the perpendicular bisector theorem to explain why triangle ABC is congruent to triangle ADC. So, hopefully you'll pause and take a minute to think about this. So, because AB is congruent to AD and CB is congruent to CD, because A is equal distance from B and D. So then by the converse, then using the converse of perpendicular bisector, theorem, we can say AC is the perpendicular bisector of BD. So by definition of reflection, point D is the image of point B. Across AC. And AC is congruent to AC by reflexivity. Okay, so let's look at some actual problems like you'll see on your homework. So determine if these two triangles are congruent. If they are, state how you know. So, is one congruent? Well, we have these these tick marks are the same, so those sides are congruent, and these ones are the same, so they're congruent. And we can get the third side by reflexivity. So the third side is congruent. And so now we have three sides in one triangle and three sides in another congruent. We can say they're congruent by SSS congruence. How about number 2? What do you think? Hopefully you said not enough information, or because we have this angle between these two sides congruent, but the angle in this other triangle is not congruent, or is it marked being congruent? We don't actually know if it is or not. So we have not enough information to say it is, to say whether it is. All right, number 3. We have all three sides marked congruent to each other. So hopefully you agree that this is side, side, side congruence. And number 4, we have three sides. They all have the matching tick marks and corresponding sides. So we again have side, side, side congruence. All right, how about number 5? What do you think? We have this side and this side congruent, and this angle and this angle. We can get this side from the reflexive property. So we can say this is congruent by side, angle, side. All right, how about the watermark here that won't go away is hiding it. See if I can move it for a second so we can see it. Okay, so we have this side and this side, and this side and this side, congruent in pairs there. This side we can get by reflexivity, the reflexive property. So we can say side, side, side congruence. Alright, so here, what information do we need to say that these triangles are congruent by side, side, side congruence? Well, we know this side is congruent. We can say that this side is congruent because of the reflexive property. So we need to know, to do side, 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 we need the third side. So we need to know that IJ is congruent to XJ. Number 12, we can get this one from the reflexive property again. So to get side, side, side congruence, we need to know that RH is congruent to FG. Right? How about number 13? To get angle, side, angle congruence, angle, side, angle means we need angle, side, angle. So we need angle Y to be congruent to angle D. Number 14, side, side, side. So we need the third side, right? So we need to know that WY is congruent to IK. And number 15, side, side, side. So again, we need the third side. So we need to know that IG is congruent to UW. This one is side, angle, side. Well, we've got these two sides congruent, and we can get this side by reflexivity. So we need to know that the two angles are congruent. Remember, it has to be the included angle between the sides, so it has to be this angle. So we need to know that angle XYZ is congruent to angle KYZ. Alright. So now we want to prove the triangles are congruent or explain why it's not possible. In number 10, we have 6 meters and 6 meters, so these sides are congruent. And we have 9 meters and 9 meters, so we have these sides congruent. And this side here, we can get that from the reflexive property. So we can say that these triangles are congruent. Oops, that's wrong. Totally wrote that wrong. So we can say these have the side, side, side congruence. Number 11. So we have this angle congruent to this angle, and we have this side congruent to this side. But look down here. This angle is 50 and this one is 51. So these are not congruent. How about number 12? What do you think? Well, we have 8 centimeters and 8 centimeters, so this side and this side are congruent. But we have a 10 and a 12 on the other two sides, and in each of these triangles here that are labeled. 12 appears to be the hypotenuse. So if this was 12, we could say they're congruent, but we don't know. And so 10 would have to be for the other side. So since we don't know, not enough info. All right, how about number 13? 7 and 8, 9 and 10. So these are not congruent. All right, so we could say 12, there's not enough information to determine, because if our hypotenuse in the second triangle is 12, then they could be congruent. Or if our longer leg in the first triangle was 10, they could be. So we don't have enough information to determine that. But in number 13, we don't have not even one congruent pair, which means chances are this one is not congruent. Since the triangle only has 3 sides, there's no way these could be congruent. One of those pairs that are given would have to be equal for it to work, to even be a possibility. All right, number 14. Mind you, I think these are in your book, so hopefully you're writing them down in your workbook. Number 14, Carol bought 2 chairs with triangular backs. For what value of x can you use a triangle congruence theorem to show that the triangles are congruent? And which congruence can you use? So we have what looks like an isosceles triangle. I don't know if you've heard that term yet or not, but an isosceles triangle has 2 sides that are congruent. And so we have in triangle GHI, we have GH is 25 and GI is 25. In TUV, we have TU is 25 and TV is 25. So we could say that these are congruent if the third sides were equal to each other. So, and if we have 3 sides congruent, then we would be using the side congruence. So solving for x, for it to be congruent, it's 9x minus 21 equal to 15. Then we have 9x, excuse me, let me fix that. Let me do the steps here so you can see them all. Equal to 15. So we're going to add 21 to both sides. And we get 9x equal to 36. Divide by 9. And we get x equal to 4. So we could use the side congruence to prove they're congruent if x equals 4. Alright, now number 15. We have 2 variables here. For what values of x and y can you use a triangle congruence theorem to show that the triangles are congruent? Which triangle congruence theorem can you use? Well, if they're going to be congruent, then we have an angle, a side, and an angle. So we can use angle, side, angle if our variables make our expressions equal. So our side would have to be equal to the other side. So 14x minus 47 equals 9. Add 47 to both sides. And we have 14x equal to 56. Divide by 14. And x is equal to, what is that going to be? X is equal to 4. So if x is equal to 4, then our sides would be equal. But we'd also need our second angles here to be congruent. So we would need to have 60 equal to 15y. And if I divide by 15 on both sides, then y has to be equal to 4. So if x is 4 and y is 4, then our triangles are congruent. All right. So hopefully that all made sense. It looks pretty easy. Homework in Delta Math. See you in class.